Okay, let us take a look at example 9, which will let you make use of the formulas that you have just learned for the expectation and the variance. Okay, so a box contains 2 red balls out of a total of 7 balls. What we're going to do is we're going to pick one ball randomly and take a look at the color. After that, we will put it back into the box. So 50 balls are going to be drawn in this manner. Meaning, first you pick a ball, look at the color, put back. Then pick another ball, look at the color and put back, and so on and so forth. Okay, so find the expected. So the key word here is expected. When you see this, means they want the expectation, the mean. Okay, so find the expected number of red balls drawn. So the random variable here will be the number of red balls that you will get. Okay, so the first step, as usual, we will always define the random variable. So let x be the random variable that denotes the number of red balls that are red out of a total of 50 balls. Okay, then followed by the definition of the random variable, you will need to define the distribution. So this is a binomial distribution. The sample size total, they are doing it 50 times, right? So sample size will be 50. The probability that you will get a red ball given by the question is 2 out of 7. Okay, because there are 2 red balls inside there. So the probability of success here will be 2 over 7. Now, to find the expectation or the expected number, we can use our formula, which is n times p. Okay, so you have the value of n, you have the value of p, sub in, n equals to 50, p equals to 2 over 7, then calculate. This will give you the expected number of red balls. Okay, the next one that we want to find is the standard deviation. Now, to find the standard deviation, we will first of all find the variance. Okay, because standard deviation is actually the square root of the variance. Okay, so again, we use our formula. The formula is NPQ, where Q is the probability of failure, which is 1 minus P. Okay, so again, same thing, sub in the value of N, the value of P, as well as the value of 1 minus P, then calculate, and this will give you 500 over 49. But you have to remember, this is the variance. Okay, the question wants standard deviation, right? So you have to take the square root of this value and that will give you 10 square root 5 over 7. Of course, if you want to leave it as a decimal number, that's also fine. Okay, now let's look at the next part of the question. We want to find the probability that x is between mu minus sigma and mu plus sigma. So you have your two values now. The value that you have found here, this is the value of mu. Okay, the value that you have found here, this is the value of sigma. So we can put that into our inequality. Okay, so we sub the two values in and then do a bit of a calculation. So you press your calculator to find the two limits. Now, because this is a binomial distribution, meaning your x, okay, is a binomial random variable, so therefore it should take integer values. So if I am between, if you can draw the number line, okay, this is 11.09, this is 17.48, right? So if I'm between here and here, then what will be the whole number that will satisfy this interval? So I have to be a whole number that is slightly bigger than 11.09, okay, and a whole number that's slightly smaller than 17.48. Alright, so then we will rewrite the inequality as x between 12 and 17 inclusive of the two ends. Now, then again, this one we cannot press calculator, right? So what we need to do is we need to convert. Okay, so I have to rewrite the inequality as a difference of 2. So you have probability of x less than or equals to 17 minus the probability that x is less than or equals to 11. So you are subtracting away the values that you do not want. Okay, then from here you can press calculator, use your binom CDF, okay, for both of them. then you'll be able to get your final answer.